Hey there, welcome back to another episode of the Pythonic Accountant. So today we're going to have another PDF file episode. This one is actually inspired by one of you guys who had a question about a previous video. So one of the questions that was posed is actually something that has really bugged me in the past, which is if you have a report that looks like this, which is a PDF file with several columns, and normally when you have a debit and credit column, if there is a blank or if there is a debit here, you would have a 0 in the credit column, and if there is a credit, then you would have a 0 in the debit column. That makes it very easy to parse because you can just say, okay, I'm expecting the name of the account here, the account number here, and then pull the two numbers at the end, and the first one's a debit, the second one's a credit. This gets a lot more complicated when there's just one number because most of the ways that you can parse data from a PDF file, it doesn't give you the position. It doesn't add an extra amount of spaces in between what's on the left and what's on the right. It'll just say, okay, inventory 630, $100. Inventory 630, $80. There's no way for you to systematically tell that this $100 is further to the left than this $80. So that's pretty stressful, pretty frustrating, and can be a headache to deal with. But fortunately today, we're going to show you how we deal with that using the pdfplumber library. So what I'm going to do is I'm going to walk you through the code and show you how we are able to get to the end results, and then break it down a little bit to explain how each of the different pieces works and why we have to use them. So let's go back over here, and the things we're going to import are collections module, which I love using, regular expressions, pdfplumber module, and pandas. And what we're going to do to start is create a regular expression to capture the ID line and at the same time capture the components of the ID line that we need. So what the parentheses represent in here are the different groups that we're capturing. And then obviously the rest is just regular expressions to capture the individual pieces within it. For each row in our data frame that we're going to create, we need to capture certain information. So we're going to get the journal ID, the description, and then who it's posted by, as well as I'm going to use this date over here. I know there's a date here as well, but I'm just going to ignore that one for now. Pretend like this is the date that is important to me. And then for each row of the journal voucher, we're going to repeat this information since we're building a data set. And then we're going to get the account name, account number, the debit, and the credit. And if we are getting a debit, we'll just make the credit 0 and vice versa. And that's why we have journal ID, description, username, date, account name, account number, debit, and credit. Now we're actually creating a few helper functions. So this one is one that we need because we are trying to find the position of debit versus credit. I'll explain later how it works. But basically, we're going to feed in a dictionary and the specific row in the file that we are in, or within the page actually, and then it's going to tell us whether the last item in that row is a debit or a credit based on the position. So if it's less than this 830, then we're calling it a debit. If it's after it, then it's a credit. This is something I often use if I'm dealing with parsing numbers that have commas and $signs in them. Pandas does not, as far as I know, currently have a way to built-in convert to a float without doing this first. And so what I'll do is just replace the $sign with nothing and the comma with nothing, and then I can turn it into a float. So now, really, this is where the magic happens. We're almost at the end already. So I have this kind of slightly bulkier function here called page2dataFrame. And what we're going to do is we're going to go through each page, and each page we feed into here. And this function takes in the lines from the page, the last position dictionary. This is kind of a funky workaround I had to do because since each page is being treated separately, you're kind of starting from scratch every time you run the page through that function. But the problem is some pages you'll have the ID information at the bottom of one page, and then it doesn't show up in the next page. And so therefore you have to take the ID information, save it, and then add it back in when you rerun it. So I'm doing sort of a hacky way of doing that, but basically I feed in a third parameter into this function called ID info, and this is a placeholder if I don't need it. but in case it does happen where I do need it, it's going to take the 5 pieces of the ID info. So I just explode that out here. So if the ID info is fed in and it actually has these elements here, it's going to then save them as these 5 variables. And then if it doesn't hit the ID line, it'll grab it from what I fed in when it goes and creates the next line of journal voucher information. And so then basically what it's doing is saying, okay, let me look first for an ID line. If I have that, then I'm going to pull out the relevant information using the regular expression groups. And then otherwise, if it has a end parentheses space $, which you can see end parentheses, this, funny enough, all of this counts as one space. And then this is your $. This end parentheses, and then all of that is just one space and then $. So basically I'm capturing a very easy way to say, I want all of the rows that have journal voucher information in them, but I don't care about these rows because they're just the total lines. So if it is a line that I want, then I'm going to grab the account name, the account number, the amount by splitting the line. And that amount, by the way, is either a debit or a credit. I have to figure that out using a separate function. The account name, I join back together, and then if the debit and credit function gives me debit, meaning using the position of where that word is on the page, then I say, okay, debit is my number and credit is 0, and then vice versa. If it's a credit, then I say debit is 0 and the credit is my number. And then I'm appending it to my rows and turning it into a data frame, and then finally returning a complete data frame from that page. And so now this last cell, I basically create an empty data frame. I create that initial parameter that I'm feeding in, and then as I go through and iterate through this PDF file, I go page by page, grab the lines, grab the words, create the dictionaries that I need, and then output this final data frame. And so it takes just a few seconds to go through, and boom, results in this beautiful output of a data frame that I can save to a CSV file. Let's just do a spot check. The last two should be a debit of $5.50 and a credit of $5.50. And sure enough, we have a debit of $5.50 to business bank account, credit of $5.50 to accounts receivable, business bank account, accounts receivable, and this should be for journal 538 payment Hamilton Smith Party. 538 payment Hamilton Smith Party, May 1st, 2020. Boom, there you go. So I think that's pretty awesome. So I'm going to break down, give you a little bit more into how we got this to work. So one of the easier parts of parsing PDF files is, grabbing the, just the lines itself. And so let's just show you how we can grab the first page. So let's say with pdfplumber, open as PDF for pages and pages, lines. And so let's just do lines equals PDF pages 0 dot extract text x tolerance equals 2, and we have to do this because if we don't, I think it gets a little bit confused. Let's see what happens if we do this. I gotta print my lines. Yeah, it's taking the inventory and saying, oh, is this multiple words? Who knows why? It's freaking stupid, but you have to give it this tolerance that says, okay, give me a little bit more. If the space is a little bit, if it looks like a space, it might not be a space, so I want to increase that tolerance a little. So by doing that, it looks much more normal. But as you can see, immediately you've got a problem here where this inventory and this inventory look like it's the same when you extract it using the extract text, but clearly this 100 is under the debit and this 80 is under the credit. So I already found out, okay, that's a problem. So the other feature you can use from pdfplumber is called extract words. So let's see what that looks like. And whoa, that's a lot more complex, a lot more stuff to deal with, probably a lot more information that I even need. So let's break this down and see, what some of this information looks like. So I care about the one where it has inventory in it. And so let's see if we can, it's even hard to read. So for line, and actually let's call this word in lines. Print word. So at least we can see it like this. So I care about inventory opening balance for blah, 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 blah. And okay, here we go. So we have inventory, 630, 100. So here is where you have to really start to dig in to understand how to get the kind of width. And so it's really, if you break down each of these, words and the things that go into it, it's actually pretty cool. So x0 and x1, that tells you the starting and ending point to a very, very specific, level of detail where that word starts and ends. So it starts at 792.92 and ends at 825.432. And then if you look at top and bottom, it's basically like the y coordinates. So the top of that word, the highest point is 163.063, and the bottom is 171.537. So I actually have to use a couple of things from this data set here, because first I have to know which row I'm talking about. So if I'm in, the fifth row from my words that I've extracted, then I need to go to the fifth row and grab the location of the text. And so what I'm using to grab the location of the text is really, I think it makes the most sense when looking at it, is the right side, because the $ moves, meaning that depending on how big the number is, that left part, the x0, is going to be in different places, but the x1, that's always going to be around the same place. So I know that if my x1 is before here, and then it's a debit, and if it's after here, then it's a credit. So if you look at your x1 for the 100, that's at 825.432. And if you look at it for the 80, that's at 904. So really anything between 825 and 904, you're probably going to be good. So I used what did I use? 830. So, that ends up being good. If I did like 810, that's going to screw everything up. And I think it's probably going to call everything a, whoops, we don't want that. Probably going to call everything a credit, see? Because it's used in the wrong place. So let me fix that before I forget. So the next thing is, and this part was even harder, is finding how to create those, which line I'm looking at. So basically, when you're looking at the lines, let's go ahead and go back to the lines. So lines equals extract text. And for line and lines, oh no, we don't want that. So lines dot split and split by a new line character. And let's print that. Actually, let's do for index line and enumerate lines dot split x split n print index line. So what this is doing is it's enumerating through this list of split lines, and the enumerate gives you an index number and then the actual results. So I can see which line number I'm interested in. So I'm like, okay, I care about line 5, 6, 7, 8, 9, 10, and that's it. And so what I can do with that information is let's show how we create this dictionary here, rows dict. So first I need to grab the words. So I'll go ahead and grab this again. pdfplumber words equals extract words. And then now let's create this rows dict. And I'll show you what that looks like. So what this is doing is this is saying, okay, I want to take the bottom. So what's the bottom of where each of these, words hits? And I'm assuming that they're all going to end up being the same place, because when I did a spot check, it sure looked like it. So each word in here has kind of the same bottom. Each of those bottoms is going to represent the next line, basically. So it's a hacky way to do it, but it works. So let's run that and then do rows dict. And cool, so that tells you, okay, my anything with the bottom of 86.110 is on the 0th row. 97.165 is the first row. So here is what I'm using to say, okay, when I look at these, the words, which has the bottom as one of the elements of it, I can now tell what row I'm in. And so now I've got the rows dictionary. I have a way to map the individual word to which row it's in. Then I need to find the last word in each row, basically the position of the last word in each row. So what I do here is I'm creating a dictionary. It says, okay, my key is going to be the row number. So rows.get. So basically I'm looking up the bottom of the word that I'm grabbing and saying, okay, which row is this word in that I'm interested in? And then the value is the second x coordinate of that word. So now I'm getting the x1 position of the word in each of these words. And I have sort of a sneaky way I'm dealing with this. So when I run this, it's actually going to create a dictionary and update the key every time it goes through each word in a line. But since I only care about the last word in the line, this is fine because anytime you update a key in a dictionary, it replaces that key with a new value. So let's show an example. So like dict a equals I, let's just use the number 0, I, 1, sup, and dict a is I 1, 1 sup. But let's say I overrode 0 again. Actually, let's do it in the new line. Dict a 0 equals yo. So now it replaces the original hi with the word yo. And that's what's happening here. So as it goes through each word, it's updating the dictionary until it gets to the last word. And then that last word gets the x1 coordinate and then moves on to the next one. And so if we run that, last position now shows that the end of each row ends in these x coordinates. And so let's look at the first one. You can see, okay, yeah, sure enough, these are kind of middle of the page. And you get to the fourth row, it's like, all right, that's near the end, near the end, near the end. 876, 855, 823, and then 904. Doon, 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 and then boom, this is your 904. So you can tell, okay, we've gone above 830. That was our, was it 830? Yeah, above 830. So, you know, each of these is actually showing up as past that cutoff point. So, well, that makes sense. This is past the cutoff point. This is past. This one's not. And then this one is. And so now we have this beautiful dictionary that tells us, is the last word in any given row, is it before my debit cutoff or after my debit cutoff? So what we do with this last position dictionary is now what we do is, okay, we're going to feed into this function up here the lines that I'm looking at, the last position dictionary that I recreate every page, and then that ID info of if we had an ID that carried over from the previous page. And then now it has everything it needs to go through and say, okay, I'm going to go iterate through these rows in this page, and if it's got the ID line, cool, create my ID. And then if it's a line with a dollar amount, now I can go through and, you know, split the line, get the dollar amount, and then run that last position and the index number of my row, because that's where it gets the index of what row I'm in. It runs it and tells me, okay, is this a debit or is this a credit? So let's actually run this. So I'm going to do my last, so debit, credit, last position, and 0. You know, that's debit, but of course, I don't really care about that one. So let's go ahead and do I think that's the 6th row or something. So let's do, maybe that's 5th. Let's just try 5. 5 is debit, and then I think 6 is credit. Sure enough, that worked. So there you have it. That is, this is definitely not a beginner level exercise, but still kind of cool to show that it doesn't take that much code. And I actually added a bunch of crap in here that I kind of have to get rid of now. But it really doesn't take that much code to go in and get your, you know, get the data that you need from a PDF file, split it up into debit and credit. But now the best part is this can be run on the same format file anytime you want. And as long as the format doesn't change, it'll give you those results that you need. So this was only a 15-page file in this exercise, but imagine if it was thousands of pages. Imagine if it came out every month or every week. Definitely something that is at least a useful tool to add to the tool bag. So I hope you enjoyed the video. If you liked it, please click like. And if you want to watch more like this, please click subscribe. And I hope you have a good one, and see you next time.